Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're continuing our exploration of concurrency in Java 9+ by diving into the improvements made to CompletableFuture. But before we get started, let's test your knowledge with a quick quiz question. In Java 8, if you wanted to add a timeout to a CompletableFuture, what would you typically have to do?
That's an intriguing question, Sheila. It really makes you think about how we handled timeouts before Java 9. Listeners, take a moment to consider this. Did you ever find yourself combining CompletableFuture with other tools to achieve timeout functionality? Keep that thought in mind as we explore the improvements made in Java 9 and beyond.
Excellent point, Victor. Now, before we dive into the improvements, could you give our listeners a quick refresher on what CompletableFuture is and why it's important in concurrent programming?
Certainly, Sheila. CompletableFuture, introduced in Java 8, is a powerful tool for asynchronous programming. It represents a future result of an asynchronous computation and provides a rich set of methods to combine, transform, and handle these future results. Think of it as a reliable courier service that promises to deliver a package, result at some point in the future, allowing you to specify what should happen when the package arrives or if there's a problem with the delivery.
That's a great analogy, Victor. So, with Java 9 and later versions, what key improvements were made to this courier service?
The improvements in Java 9+ focused on making CompletableFuture even more robust and flexible. The most significant additions were new methods for timeout handling, enhanced exception management, and better support for customization. Let's start with the timeout features. Java 9 introduced two new methods, orTimeout and completeOnTimeout. These methods allow us to specify a timeout directly on the CompletableFuture without resorting to external tools.
That sounds really useful. Can you elaborate on how these new timeout methods work?
Absolutely. The orTimeout method allows you to specify a duration after which the CompletableFuture will complete exceptionally with a timeout exception if it hasn't already completed. On the other hand, completeOnTimeout lets you provide a default value that will be used to complete the future if it doesn't complete within the specified time. These methods make it much easier to handle scenarios where you need to limit the wait time for an operation.
I see. So, if I understand correctly, orTimeout is like telling our courier, if you don't deliver within an hour, consider the delivery failed, while completeOnTimeout is more like saying, if you don't deliver within an hour, just leave this default package instead. Is that right?
That's an excellent way to put it, Sheila. Your analogy captures the essence of these methods perfectly. Now, let's move on to the improvements in exception handling. Java 9 introduced a new method called exceptionallyCompose, which allows for more detailed control over exception handling and recovery strategies.
Interesting. How does exceptionallyCompose differ from the existing exceptionally method?
Great question. While exceptionally allows you to provide a direct value in case of an exception, exceptionallyCompose lets you return another CompletableFuture. This is particularly useful when you need to perform another asynchronous operation as part of your error handling strategy. It's like giving our courier a backup plan that might involve another delivery attempt or a completely different package.
That makes sense. Now, you mentioned something about improved support for customization. Can you elaborate on that?
Certainly. Java 9 introduced several protected methods in CompletableFuture, such as completeValue, completeThrowable, and others. These methods make it easier to create custom versions of CompletableFuture with specialized behavior. This is particularly useful for advanced scenarios where you need to integrate CompletableFuture with custom execution environments or add domain-specific functionality.
I can see how that would be valuable for more complex applications. Are there any performance improvements worth noting?
Indeed there are, Sheila. While not as visible as the new methods, Java 9 and subsequent versions have made various internal optimizations to CompletableFuture. These include improvements in memory usage and execution speed, especially for common patterns of usage. However, it's important to note that the impact of these optimizations can vary depending on the specific use case.
That's great to hear. Now, let's talk about real-world applications. Can you give an example of how these improvements might be used in a practical scenario?
Certainly. Imagine you're building a web service that collects data from multiple external sources. You could use CompletableFuture to make these calls concurrently, and then use the new timeout methods to ensure that your service remains responsive even if one of the external sources is slow. For example, you could set up a CompletableFuture to call an external API, but if it doesn't respond within 5 seconds, it would complete with a default message like API unavailable, instead of waiting indefinitely.
That's a clear and practical example, Victor. Are there any common pitfalls or best practices our listeners should be aware of when using these new features?
Great point, Sheila. One common pitfall is overusing timeouts without proper error handling. While timeouts are useful, they shouldn't be your primary means of dealing with slow operations. It's important to understand why operations are timing out and address the root causes where possible. As for best practices, I'd recommend 1. Always provide meaningful timeout values based on your application's needs. 2. Use exceptionallyCompose for more complex error recovery scenarios. 3. Be cautious when customizing CompletableFuture. Only do so if you really need custom behavior that can't be achieved through composition. And 4. Remember that CompletableFuture is not cancelable once it's completed, so design your asynchronous operations accordingly.
Those are valuable tips, Victor. Now, I think it's time we revealed the answer to our quiz question. In Java 8, if you wanted to add a timeout to a CompletableFuture, you would typically have to combine it with other utilities like executor services schedule at fixed rate or use external libraries. The introduction of orTimeout and completeOnTimeout in Java 9 greatly simplified this process. Victor, any final thoughts before we wrap up?
Absolutely, Sheila. I think it's worth emphasizing that while these improvements may seem small, they significantly enhance the usability and power of CompletableFuture. They address common challenges developers faced with the Java 8 implementation, making concurrent programming in Java more accessible and robust. As always, I encourage our listeners to experiment with these features in their own projects to truly appreciate their value.
Thank you, Victor, for those insightful comments. To summarize, we've covered the key improvements to CompletableFuture in Java 9+, including new timeout methods, enhanced exception handling, better customization support, and performance optimizations. These changes make CompletableFuture an even more powerful tool for managing asynchronous operations in Java. In our next episode, we'll be discussing the Stack Walking API, another exciting feature introduced in Java 9. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you've enjoyed this episode. Your feedback helps us create better content for you. Until next time, happy coding.